The chemical energetic, the last week we discussed this topic in which uh, there are two types of chemical reactions in terms of energy change. A reaction can be an endothermic, which take in energy, and the reaction can be an exothermic, which gives out energy. So the first exercise is related to planning of the experiment alternative to practical. You will find in paper 6 that they asked to plan an experiment. So this topic is totally related to planning of the experiment. The first part, when a cement powder is added to water, a reaction takes place. Describe an experiment to show that this reaction is exothermic. So we want to make sure that the reaction is exothermic or the reaction is releasing the energy. So how we can make sure this that the reaction is exothermic? So we'll take example 10 cm cube of water into beaker. Then we'll measure the initial temperature or the starting temperature. Then we will add the cement powder. Then what we do, we'll record the final temperature. So if the reaction is exothermic, so the final temperature will be higher than the initial temperature. Because the reaction is exothermic, that is releasing the energy when we add a cement powder to water. So the water temperature will increase. So example, we have a container and that container is, we filled it with water, like 10 cm cube of water. So if we fill the container with 10 cm cube of water and we measure the initial temperature, we don't have to mention any value, but I'm just using the numbers here. Example, we measure the initial temperature or starting temperature, say it was 30 degrees centigrade. Then what we did, we add a cement powder because we want to show that when we add a cement powder to water, the reaction is exothermic. So when we add a cement powder, like these dots are representing the cement powder. So when we add the cement powder, the reaction is exothermic. Exothermic reaction means it releases energy. So when cement powder will come in contact with water, the cement powder will release the energy, and that energy is absorbed by the or taken by the water. So when cement powder loses energy, water will take energy. So what will happen? The temperature of the water will rise. Example, the final temperature is 33 degree centigrade. So if the final temperature is higher than the initial temperature, so this simple experiment proved that addition of a cement powder to a water, it's an exothermic change or energy is released or given out. Is it clear, this example, the first experiment? Anyone having a doubt? So whenever the reaction is exothermic, that releases the energy, so the temperature of the water, if a substance is present in water, so temperature of the water will increase. Any doubt in this part? Is it clear to everyone? The first experiment. Okay, moving on to the next question, that is question 2. These all questions are from paper 6 in which you have to plan the experiment. So the second question is plan an investigation to show that three different types of nuts produce plan an investigation to show which of the three different types of the nut produce the most energy. You have peanuts, you have Brazil nuts, and you have hazelnuts. So how you can prove or how you can work out or how you can find that when we burn these nuts, which one produce the most energy or which one the burning is most exothermic. So for that case, the water is a simple thing we can use. What we do, first I will draw the experimental setup and then I will write this experiment. So first what we do, we'll take equal amount of peanuts, Brazil nuts and hazelnuts. So we'll take equal amount, equal mass, equal size of peanuts because for a fair comparison, we should have equal mass of each type of nut. Then we'll place these nuts under a beaker which is filled with water. So what we do, we place these nuts under a beaker which contain equal amount of water. Like example, normally like 10 cm cube is okay, fine. You can mention any amount, but it should be equal amount. Then what we do, we measure the initial temperature or the starting temperature. So example, and all should have the same starting temperature for a fair comparison. Say in case of peanut, the water temperature is 30. In case of Brazil nut, the water temperature is 30, and in case of hazelnut, the water temperature is also 30. Now what we do, we burn these nuts. So when we burn the nuts, the combustion of burning is exothermic. So what will happen? They will produce heat energy, and that heat energy is absorbed by the water which is present in the beaker. After that, once the combustion or the burning is complete, once they burn completely, we'll measure the final temperature. Example, the final temperature of water which is there when peanuts are burned, that was 40. The final temperature when Brazil nuts are burned, that example 38. And the final temperature when hazelnuts are burned, say the temperature is 33. The final temperature. So which one you think produce the most, which type of peanut produce, which type of nut produce the most energy? Brazil nut, peanut or hazelnut? So in this case, peanuts produce the most energy because the water temperature rises to greater level or change to greater level as compared to Brazil or hazelnut. But again, in exam, you don't have to mention which nut produce, you just have to plan the investigation. How you can do this experiment. Is it clear the experimental setup? Then I will write the answer for this because it is important you understand the experimental setup. Any question or doubt in the experimental setup? So same what we discussed experimental setup, that will be the explanation. So what we will do, we will take equal masses of peanuts, Brazil nuts, and hazelnut. So we take equal masses of the three types of nuts. Then we will fill 3 beakers with same amount of or same volume of water. Then we'll record the initial temperature. Initial means the starting temperature. And we'll burn the nuts which are placed under the beaker, and we will record the final temperature. And how we can be sure that which nut is producing the most energy, that the nuts which cause greater change in temperature of water is producing the most energy. So this is how we plan this experiment, that we burn. And in exam it's better, like even it's not mentioned here that you should draw a figure, but for to support your answer you should draw a figure. A rough figure is acceptable, so that in case if you miss any point in the explanation, your diagram will cover that point. Is it clear, the second experiment, that how we can show that when we burn different types of nuts, which one produce the most energy, how we can plan or investigate? Then question 3, it's a similar question. We have diesel is a liquid fuel which is obtained from a crude oil, like petroleum or crude oil is there. Crude oil is actually a mixture of different types of oils, which consists of diesel, petrol, and kerosene. So biodiesel is a fuel which is made obtained from the oil, or made from the oil obtained from the seeds such as sunflowers. Using the apparatus, plan an investigation which of the two fuels produce the most energy. So it's a similar experiment. First I will draw and explain, and then I will write. Because the diesel is there, or biodiesel, both are liquid. So when we have a liquid fuel, what we do, we take liquid fuel in a spirit burner. So we'll take the spirit burner. So what we do, it will be filled with equal amount of diesel. The one is containing diesel, another one is biodiesel. Biodiesel, basically a diesel obtained from the plant seeds, known as a biodiesel. So what we do, this is a spirit burner. So here a wick is attached. Here also there's a wick. So when we burn this, it will produce heat energy. So we'll take equal amount of water. It can be in a test tube. So we'll take equal amount of the water in the two test tubes, and we will record the initial temperature. Like example, initial temperature for this one is 30, the other one is also 30. Then what we do, we burn them. We burn biodiesel that produce heat energy, and we burn diesel and biodiesel, both will produce heat energy. How we can identify which fuel produce the most energy? So the one which shows a greater change in temperature. Like example, when we burn diesel the temperature changes from 30 to say 38. But when we burn biodiesel, the temperature changes from 30 to 35. So which one is producing more energy, diesel or biodiesel in this example? When we burn equal amount of diesel and biodiesel, the temperature change by combustion or burning of the diesel, yeah, that's right, Afrin, that because the combustion it's producing more energy, that's why there's a greater change in temperature for diesel as compared to that of biodiesel. So it's the same experiment, but the only difference, in the previous experiment we were burning the nuts, and when we are burning the nuts, because it is a solid, so we just directly burn them. But for when we want to burn a liquid, so it should be inside a spirit burner, so that when we burn, because liquid must be inside a container so that we will not lose the liquid, and we burn this in a spirit burner. So how we plan this experiment? So we'll take equal volume diesel and biodiesel in spirit burner. So we are taking equal volume of diesel and biodiesel in the spirit burner. Then we'll fill the test tube, or you can also say beakers, with same amount of liquid, that is water. Record the initial temperature of the water. Then we'll burn the fuels. So we'll burn diesel and biodiesel completely and record the final temperature. So when we burn them completely, we'll record the final temperature. So the test tube or the beaker, which shows greater change in temperature, represent the liquid or the fuel which produce most energy. Is it clear, this experiment, that how we can work out that which one produce the most energy when we burn? So we take equal amount of the two liquids, we burn them, we take equal amount of water in the container. The one which shows a greater change in the temperature, the experiment in which there is a greater change in temperature, that is the most exothermic or produce the most energy. Is it clear, the third experiment? Any doubt? Any question or a doubt in this experiment? Then another experiment. In this question, a student investigated what happened when dilute hydrochloric acid and copper 2 sulfate solution react with different metals. So this is experiment is done. Like student is finding what happened when hydrochloric acid reacted with dilute hydrochloric acid react with copper 2 sulfate solution. A measuring cylinder was used to pour 10 cm cube of liquid into a boiling tube. The temperature of hydrochloric acid is measured, then 1 gram of zinc is added and stirred. Then experiment 2 is repeated using 1 gram of iron. Then experiment 3 is repeated with 1 gram of magnesium. Use the thermometer diagram to complete the final column. You can use the screen annotation to complete this. What is the thermometer reading initial? This is 20, 21, 22. The first one I did, I want to complete the column. You don't have to write degree centigrade. You just have, because it's already mentioned, so you just have to mention the number. What is the maximum temperature here? It's 23, right? 61. And what about the difference in the temperature? 61 minus 24. The difference in the temperature, it will be 61 minus, so that will be 37. So this one is 37. So the temperature here was 3, 2 and 37. Then complete for this part. Experiment initial temperature. What is the initial temperature? 21. What is the final temperature? 46. What is this temperature? 46 minus 21, 25. And this is 29 minus 24, so that is equals to 5. Then we have to draw a bar chart. So we have to draw a bar chart for experiment 1, 2, 3 and 4. What was the temperature change for experiment 1? If you anyone remember experiment 1, what was the temperature change? Because only for experiment we have to draw a bar chart. Experiment 1 was 4. Just a minute, I will check. So experiment 1, 25 minus 21, so that is equals to 4. What about experiment 2? It was 23 minus 21, so that was 2. Experiment 3 was 37. Then experiment 4 and 5 are there on the next table. 46 minus 21, that was 25. And this was, so 29 minus 24, that is 5. So these are the experiments. We have to draw a bar chart to show our result. So example, 10 boxes equals to 1, 2, 3, 4. So 10 boxes equals to 5. This is 10. 15, 20, 25. But I have 37, so the 37 should be there as well. So we always select the scale which is having all the numbers. So if we are not able to work out any of one of the number, then we'll change the scale. But what will happen, I'm roughly sketching for experiment 1, it was 4. So experiment 1 was 4. This is a rough sketch, it's not the exact. So experiment 1 was 4. Then experiment 2 is 2. Then experiment 3 is 37. So experiment 3 will be 37. Then experiment 4 is 25. Then experiment 5 is 5. So this is how we sketch, and you have to label, like you have to mention, like this part is experiment 1, experiment 2, experiment 3, experiment 4, and experiment 5. So this is a bar chart for representing the change in the temperature for 5 different reactions. Next question, which experiment 1, 2, 3 produced the largest temperature rise? Largest change in temperature. Experiment 1, 2, or 3. So experiment 3, that's right. And reason, we'll not discuss the reason right now. Why? Because that is related to another chapter. It is related to about the reactions, the particle size, rate of the reaction. So that's next chapter we'll discuss. So I'm not discussing the reason right now. The other parts are related to another chapter. Another similar question is there. Use the thermometer diagram, record the temperature in the table. What is the initial temperature? 21. What is the final temperature? 32. Initial temperature 21, final temperature 37. Initial temperature is 21, final temperature is 48. Here we don't have to write the change in temperature because in the question they did not ask for that. Another initial and final initial and minimum temperature. So 23, 20, yeah, 18 is there. So these are the values for initial and so basically what happened, as you can see here, the temperature is decreasing. It means the reaction is endothermic. How the reaction is endothermic? Because water is not the reactant here. The particles which are present inside the water, the reactant particle, like the red color is representing the reactant particles. So these are the reactant particles. So the reactant particle take energy. From where they will take energy? The reactant particle take energy from the water. So when the reactant particle take energy from the water, the temperature of the water will decrease. That's why whenever a temperature of a solution or temperature of the liquid decreases, it means the change is endothermic. But the previous When we complete these tables, initial temperature like here was 21 and the final temperature is 31, 32. So what happened here? The reactant particles, like example, the red color is representing the reactant particles. So these particles, exothermic reaction, they release energy. So when they react, they give out energy and that energy is absorbed by the water. That's why the water temperature is increasing. So always remember, whenever the temperature of the water or the solution increase, it means the reaction is exo. And if the temperature decrease, then the reaction will be endothermic. So we have to sketch a graph here, temperature of a solution, best fit line we have to draw according to the values. The remaining parts are not related to the topic, it's related to another chapter. Use the thermometer diagram to record the temperature in the table. What are the temperatures in the table? Can you complete using the screen annotation? You can just state the value, temperature reading. So these are the temperature values 23, 16, 14. So what we are observing, the temperature of the solution is decreasing. If the temperature of the solution is decreasing till this point, what we can conclude or what we can say? Reaction is endo or exo? If the temperature of a solution is decreasing, so if the temperature is decreasing, it means the reaction will be endothermic. If the temperature of the solution increase, it means the reaction will be exo. What about this result? You can use screen annotation to complete the table, the values for temperature. So when we observe, it started with 22. The temperature reading started with 22 and it reaches 35. So when temperature increase, what we call that reaction as exothermic. So remember these points. It is very important because the next session will do multiple choice questions. So you have to identify whether a reaction is endo or exo in terms of temperature change as well. So this was exercise related to the chemical energetics.